In this video we want to make the axle system, and so we're going to use the existing geometry from the box, and so we're going to start with the box structural part studio, and then we're going to make these parts right here, and we're going to use this drawing to help us. This is one that we'll make eventually, and it's kind of a overall drawing that shows the dimensions of our system, and we're going to need to use a couple of these dimensions here. So you have this available to you. So let's go to Onshape in the box structural tab, and first I'm going to place a sketch on the right side of the box, and I'm going to use that circle, and then I'm going to extrude, and I'm going to use a second end position. So we have to decide how far we want to extrude from this far right face in either direction. And if we go to this drawing here, you can see that you can't see it here actually, but the axle comes out a distance 0.25 on this side. So we're going to want to extrude 0.25 in one direction, and then we're going to want to also extrude, again we're extruding from this face right here, we're going to want to extrude in this direction a distance 6.75, which is a distance from the right edge here all the way to a 1/4 inch past the left edge of the box. So 0.25 and 6.75. Let's do that. So this one we'll do 0.25, and this one we'll do 6.75. And there we go. So if you view this in the front view, you can see that it looks correct. So we're going to go ahead and go with this. So let's immediately rename that part as the axle, and we'll change the material properties later. At this point, let's make the axle collar over here, and so we just made the axle, so it was 7 inches total. It was a diameter of 0.25. The axle collar has an inner diameter of 0.25 and an outer diameter of 0.5, and it goes on the end of the axle on the left hand side to prevent it from dropping off. So, and that's 0.25 out. So let's come here, and I'm going to hide the axle and then put a sketch on this face and use that hole, and then make another circle here of diameter 0.5, and then extrude that out a distance 0.25, and that's going to be a new part as well. So that's our axle collar, and if we turn on the axle you'll see that it looks to be okay. So we'll change that part's appearance and material in a minute. So rename, that's the axle collar. Okay. Now we want to make the crank arm. So let's go to the crank arm here in the dimension drawing, and to do this we're going to make a circle here, kind of like with the pear cam, and a circle here, and then connect them with the straight lines. And we've got a radius of 0.5, so it's going to be a diameter of 1, and a radius of 0.25, so that'll be a diameter of 0.5, and it's 0.25 inches thick, and that should be enough for us to make that. So again, I'm going to turn off the axle and put a sketch here on the right hand side, and then again I'm going to use this hole there, and then this is going to come out 1, and again that's a result of the radius here being 0.5. So I'm making this circle right here, and another circle will be 0.5 in diameter or 0.25 in radius, and then to fully constrain it, we'll go this separate distance here is 1.5, I think, and let's check that. So that is 1.5 there. Alright, now we can do what we did with the pair cam and put the straight lines here to connect them, the two circles. And you can see that I think I'm going to have trouble here with this one because it picked up this coincident constraint right here. So I'm going to delete this one and make it again and be more careful that I don't accidentally get a constraint as I place the line. Now let's go to tangent. So we'll go there, and there, and there, and there, and there, and there, and then we'll trim away the stuff we don't need. And now let's place the hole for the axle or crank arm peg, and that's is 0.25 inches in diameter. And now we can extrude in this area here, and we want to come out 0.25, and that is we want to make that a new part rather than add on to an existing part. So that will be the crank arm. And we'll change its appearance and material later. So if we turn on the axle, it looks like we have everything good so far. Now let's put it in the axle peg. So let's put a sketch on this face. And again, we're going to use this circle. I'm going to turn off the crank arm's visibility, because what I'm going to do here is I'm going to go in two different directions again on my extrusion. I'm going to go 0.25 that way, and then I forget how much farther I come out here. So let's see. Its total length is 1.25 and its diameter is 0.25, of course, so I got to come out, I guess, 1 in the other direction. So let me do that extrusion now. Extrusion right here. And if I look at it in the front view, I'm going to have a second end position. So the first one, 0.25. Nope. I think we want that to be 1, and the other one to be 0.25. Like so. We do want that to be a new part, so we'll accept that. And then we can turn back on the crank arm and rename the one we just made to be the crank arm peg. And that should do it. That should make our axle system, which consists of, let's see, 4 parts. Let's make sure that's what we're supposed to have. 1, 2, 3, 4. Yep, so it looks like we're okay with that one. Thanks for watching.